Hello and welcome. In this video, you are going to learn how to use UCINET for calculating the different centrality measures that we talked about in class. You will also learn how to export a UCINET file into Excel. This will allow you to carry out statistical analysis that are more sophisticated to the ones that you can compute in UCINET. So let's go back to the UCINET interface. If you're going to calculate centrality measures, then you have to go to the Network tab and then Centrality and Power. Here you can see the menu of different centrality measures that you can compute. If you're interested in calculating only one at a time, then you can just simply click on the preferred centrality measure. But if you're interested in calculating multiple measures, then you go to Multiple Measures option and click there. Now, we have already set up our input and output folders, so this makes it easy for us to locate the files that we want to read in the location where we want to write our files. So let's select the Paget file. This is the one that we're going to work with today. We select that, and please note that UCINET data files have the extension ##h. Select that, open. And then automatically under output measures, we can see that the field is automatically populated. Because UCINET knows where our output folder is, then we know for sure that UCINET is going to write the file to that destination folder. And that file is going to be called, as indicated here, paget-send. That file is going to contain all the centrality measures that we ask UCINET to compute. The file that we're going to be using, Paget, contains two different types of networks. One is a marriage network, and the other one is a business network. And these marriage and business networks contained in this dataset belong to a set of Florentine families from the early 1400s back in Italy. Now, when we calculate centrality measures, we have to indicate some information to UCINET. The first one is we need to indicate whether the data is directed or undirected. Alternatively, we can let UCINET guess and auto-detect the nature of our data. Since you should know how the data is collected and how the data should be, it is better if you tell UCINET whether data is directed or undirected. I do not advise you to select the auto-detect. In this case, the networks containing the Paget dataset are undirected. Next, we want to indicate the value of the ties. So far in this course, we have only been discussing whether ties exist between two nodes, yes or no. That means that our ties are binary. They can only take on two values. They exist or they do not exist. There are ways to give a value or a weight to ties. That is, you can use a measure that is referred to as tie strength. But that is outside the scope of this course. And the data contained in this Paget dataset is binary. So we can also ask UCINET just to keep it binarized. Now remember from our lecture on network centralities, I told you that sometimes closest centrality cannot be defined. And it cannot be defined when there is no path between any two nodes. So the path does not exist, there aren't any ties, and the path is undefined. And as a result, closest centrality cannot be computed. You can tell UCINET how to deal with these type of issues. I prefer to let UCINET replace missing undefined distances as 0, because it just simply indicates that the closeness centrality between any two nodes on average is just 0. So then all the paths, like, they cannot be used for calculating close centrality, we just get a value of 0. Next, we can indicate UCINET whether we want raw scores or normalized scores. Raw scores are those that are just simply calculated using the formula that I gave you in class. The normalized ones, if you remember, are those where you account for the size of the network. Normalizing centrality scores allow you to compare across networks. But since we're not really interested in comparing networks at this point, we can just keep the raw scores. Next, we can tell UCINET the measures that we want it to calculate. In this case, we're going to choose degree centrality, between centrality, and eigenvector centrality. Once all your wishes are set, then you can click OK. Now, these notepad windows are going to pop up every time you do something in UCINET, and this is where you're going to find out whether what you did worked or whether it didn't. First of all, let's look at this. It read a dataset from the input folder that is called Paget. It generated a dataset, Paget sent, and it was saved onto this folder. The data was treated as undirected, and the data was considered, the ties were considered as binary. So is there a tie, yes or no? The scores that were calculated are raw scores. Now, I told you that this dataset contains two different types of networks, a marriage network and a business network. So here we have the output for the marriage network, and this is the output for the business network. And the three centrality measures that we asked UCINET to calculate are reported here. So you see we get degree centrality, eigenvector centrality, and between the centrality. And we get that measure for each node in the dataset. In this case, each node corresponds to one of the 16 Florentine families in Italy in the early 1400s. Now, this data set as it is, or this report as it is not very useful, right? We cannot do much with it. It's not very friendly for doing any further analysis. Now, let's look at our output folder where the data was actually saved. And what you can see is that is this. So our input and output folder now contains our centrality file that was generated by UCINET. But also, this is not very useful because having a UCINET file does not allow us to do anything else with it, right? Usually, we may want to compute analysis in Excel, using Stata, using SPSS, you name it. So the next step is to actually export this information. So basically, those H files contain this information, and we want to generate an Excel file with it, and then we can do more with it, more with our data. So in order to export files from UCINET to Excel, you have to go to the Data tab, Export, and choose Excel. Pretty straightforward. Then you can tell UCINET which file is the one that you want to create as Excel, export to Excel. Let's pick the centrality file. And because we already indicated our output folder, it's just going to generate that file directly on the output folder that we have indicated to Excel. If you prefer another folder, you can select it by clicking on the ellipsis. Then we can also tell UCINET what type of Excel file we want, if we want an XLS or XLSX, the newest version of Excel. I'll just pick XLSX, doesn't really make a difference. unless you have a large data set with more than 255 columns. So let's click OK. We get another Notepad window telling us that it read a file and it generated an Excel file that is located on this folder, and that file is called pagetSent.xlsx, and it is this form of Excel file, and it was successfully saved. Now let's look where it is. We go to our destination folder, and here we find our Excel file. Let's click on it. And here we see that the Excel file has two tabs, one for the marriage network and another one for the business network. And all this data has been generated. Basically, the report that we saw in Notepad, the Notepad report, is included here. So now you can do all sorts of analysis using Excel and the type of skills that you have. You can import this Excel into Stata, into SPSS, into R, whatever you want to do with it, and you can compute more specialized type of analysis. Now, we have two networks. How about if you want to compare both of them? You can calculate the normalized centralities, right? How about you try to do that by yourself? Good luck.